Nearly half a century ago, Oracle transformed how the world managed data. More than a decade ago, we reimagined how business works in the cloud. And now, as AI reshapes how we operate, compete, and innovate, Oracle is once again leading the way. That data, it's now your AI fuel. That cloud, it now trains and runs the world's most powerful AI models. And those models, they power the Gen AI built into your business processes and the AI agents that automate it all. Oracle brings AI to every corner of your business so you can imagine beyond the boundaries of what's possible. Whether it's leveraging AI to increase productivity, make decisions faster, and save money, using AI-powered forecasting to secure and maintain a power grid for millions of customers, training AI models to make the world's most powerful particle accelerator run faster and more efficiently, or harnessing AI vector search to tackle antibiotic resistance. We help you stay ahead because Oracle was built for the era of AI, so we can build the future of AI for you.
Please welcome to the stage, Mahesh Thiagarajan.
Hello everyone, good afternoon. AI changes everything. There hasn't been a piece of technology that mankind has ever invented that has seen a tremendous amount of change in such a short span of time. And what this fundamentally does to a lot of what we do every day is significantly going to change. But while that is changing, the hard part is marrying where we are today and the applications and the infrastructure that we run today, and how do we reach that future world. And a lot of what we do in data centers, things that we maintain around on-premises applications or infrastructure, is just not going to move as fast. Second, I fundamentally see how teams are innovating and building applications. That's fundamentally changing, where smaller teams and leaner teams that are powered with AI tools and apps are starting to deliver faster results than a general, siloed, individual, large, fragmented teams and structures. Third, as the advent of AI and the speed accelerates, it is very clear that the security challenges are going to continue to rise. There's more and more multi-cloud, there's more and more new tools that customers have, but figuring out how to actually have a conscious security strategy that protects you and your data is very important. And so I fundamentally believe the innovation in the cloud is something that should be accessible to everyone, and everyone should have ability to move and adopt cloud. And second, give you the tools that is required so you can accelerate your business with AI. And our philosophy fundamentally comes down to bringing you a cloud with all of our services, no matter where you are. And second, offering you a fundamentally performant, price economic AI infrastructure platform that gives you flexibility and choice. So today, I'm going to talk in depth about how we built our cloud, what's different, why do customers like us across both of these pillars. And what I like to joke about is that if you're not someone that likes to hear about the engine in a car, this is not a great session for you, because I'm going to talk about the engine and building the engine. Okay? All right, let's jump into distributed cloud. A quick high-level note, OCI has been around for over 9 years. We had a foundational approach in terms of how we built the cloud, starting from infrastructure for it to be most performant, flexible, with the highest security. But that was the bedrock. But then over time, we added 144 plus cloud services that is completely available, so you get a fully featured cloud in your hands. Second, Oracle's the only company that has actually held all of the business critical, mission critical data in Oracle databases globally across all enterprises. And so we made it easy to bring Exadata as is on Oracle Cloud Infrastructure. And not only that, if you went to buy coffee today morning, you took an Uber ride here, if you checked into your flight on British Airways, all of you have probably interacted with an Oracle technology today. And more often than not, most of the companies out there use Oracle technology, and we're on the behind making customers happy. But what this means is that a full stack experience is offered by Oracle, starting from infrastructure to database, all the way to applications, both on Fusion and custom applications. All right, so a quick primer. Oracle was, OCI was started in 2016. We started in one region out in the corner in Phoenix. But you fast forward to today, we have last year we had over 41 commercial cloud regions with another 3 added to about 44 today. We have another 11 planned, going over to 55. And you think about our multi-cloud strategy of bringing our most valuable database platform in access to every single enterprise customer who's actually made their choice about another cloud. We announced this a couple of years ago, but since then, we had about 11 regions for multi-cloud in 2024. Now we added about 27 just in the last year, and we have about another 33. The most important part about this particular growth or trajectory is to understand that Oracle is moving at the speed for you to get access to the tools and choices with AI that as you need. Another important challenge and feedback that customers have been giving us with multi-cloud is that we realize customers use more than 2 clouds in many cases, and it is important for them to leverage the procurement, to actually have a streamlined procurement process. They can actually have universal credits, they can grow their applications as they see fit in each one of these clouds. And so that workload portability and flexibility is foundational for how customers build multi-cloud apps, and Oracle enables that, and we're deploying more and more regions so you can take your data, be secure in an Oracle database, and use it with the tools of your choice, be it in any cloud. Dedicated regions is a fundamental differentiator in terms of how Oracle brings all of its cloud services to where customers need. And we had about 18 regions in 2024, which is just last year. We've added another 20 just in 2025, and we're adding another 22 over the next couple of years. And that is a phenomenal growth as more and more enterprises are not only betting on Oracle Cloud Infrastructure for their services and infrastructure, but also bringing AI closer to where the data is at. Okay, when we talk about dedicated regions, one of the things that's important is to kind of give you a perspective of where we started and where we are, because it gives you an insight into why Oracle Cloud Infrastructure is the best platform of choice for your infra workloads. Because in 2022, we launched the platform with 56 racks. With all of our services, we didn't change any of the code. Anything that's available in the public cloud is available here. But you go to 2023, we continue to innovate to make sure that we brought that number down to 36 racks. And you fast forward to 2024, we now were able to deploy all of our services in about 13. And today, we are announcing GA of Dedicated Region 2025 in 3 racks. And the most important part about this announcement, as you saw in those pictures, is not just about getting an isolated space in your data center, but actually being right next to your racks and in a disintegrated way, so you don't actually have to worry about finding space for putting in a dedicated region. And another key part about doing this work is that in addition to placing it right next to it, we also have security properties that's inbuilt, so you can place these racks anywhere. What that means, it actually allows you to get more capacity, because these are data centers that you pay for, and you do not want tile space that Oracle actually keeps in a corner. And it goes back to the foundational principle that I talk about, continuous innovation at the infrastructure level that allows you to get the latest and the greatest. And so everything that we offer is available in every single region, including the DRCC and Alloy. All right, now what I'm going to do is I'm going to pop the hood, talk to you a little bit about our foundational principles and tenets in the way we build our cloud. First principle that we actually have is giving customers the utmost flexibility and choice. The second is to have the highest performance with SLAs. And third, make sure that it gets you the best price economics. And we're going to talk through the details about why I say that and how the industry trends have shaped up. When it comes to compute, OCI was the first cloud provider to launch bare metal with the root of trust, ensuring that the full raw power of bare metal was available in a single click and provisioned just like a virtual machine. But we did not stop there. We said, hey, why does the world need to be offered only the Lego blocks that every other CSP out there decides to offer? Why do customers have a shape that is 1 core and 7.5 gigs of RAM? Why is it 1 core and 15 gigs of RAM? Why can't it be 1 core and 3 gigs of RAM? Right? And so that fundamental thought enabled us to invent compute flexible shapes, which a lot of customers today enjoy, because workloads that are sort of spiky, workloads that need sort of licensing terms, all of those workloads now end up getting lower costs when you run that on infrastructure. And I want to show you what this means in terms of savings as you think about you placing large workloads in applications in your platform, and you plot that curve about using those cores relative to how you would spend them on OCI. Is a very simple cost curve that shows you the savings that you get by actually using flexible shapes in OCI. Let's talk about the network. I don't think people talk enough about the network, so I'm going to talk a lot about the network. But it is very, very foundational in the way we thought about our cloud, because the network is at the heart of any application, but it's invisible, but it is foundational to what we do. So we started out with a non-blocking, max performance, non-over-provisioned network in OCI. That is the foundational bedrock. And if you think back why we did what we did, we had decades of experience with Oracle databases to know that this is sort of a foundational technology. If you actually get the network right, you can enable any application to use the best of the hardware, both on the compute side and over the network onto any remote storage system. And we also continued the journey of offering flexible load balancers, so customers can build applications without worrying about what shape to choose depending on what kind of load or traffic patterns they're going to get. And we applied the same philosophy and principle to storage. We went for out-and-out maximum peak performance that the drives could offer on our block storage service. And not only that, we also tuned it to figure out how to enable customers to spend less when they're not actually using those volumes. So Oracle has one particular volume type, and anytime those volumes are not fully utilized, we do intelligent tiering on the back end, which fundamentally moves a couple of copies down to our object storage platform so we can pass those savings back onto you. So it's a foundational logic and technology that we build that ensures we continue to innovate for you, but pass the savings back to you as a customer. So OCI has the industry's first and most flexible infrastructure across compute, network, and storage, enabling you to truly pay as you go, not what you actually provisioned. Now, let's talk about choice. While I offer a flexibility across the platform, choice is important. We understand that customers may have certified applications or are passionate about using AMD or another choice of their platform of their choice, and we want to bring a plethora of choices that is very focused on giving you the price economics. And so we've fundamentally believe it should be a silicon that is of your choice. So we offer AMD, Intel, and Ampere, which is very, very optimized on price performance. And today, we're announcing the next generation of shapes for OCI compute with Intel's X12 platform. We're also announcing Ampere's A4 standard platform, which is an out-and-out performance strategy that we're very excited about. So, all right, we've got a very flexible platform, lots of choices, but it doesn't mean anything if you do not get the performance. And also, performance on paper doesn't mean anything if you don't actually have SLAs at back end, from our perspective. So, on the compute side, Oracle is the only cloud provider that actually doesn't do any sort of over-provisioning and gives you the full physical cores. An OCPU is an OCPU that is actually at the hardware layer. And on the network, I talked about giving the 99.9% network throughput and SLA, and we're the only cloud provider that publishes the numbers of how much network throughput you can get on every single instance. And on storage, we give a performance back SLA on our storage platform. That's great, but with the advent of AI, it is very clear that the new challenges for storage is actually continuously increasing. Because when you think about these large AI clusters that are getting built, every single GPU is looking to get a tremendous amount of storage and tremendous amount of bandwidth down to the storage layer for it to do the work. And so as you look at some of the new demands, the extreme performance requirements from these GPUs, which probably even expect 10 to 20 gigabits per second out of the storage platform, pushes the current the nature of how storage is done. Second, while you can put a very expensive storage platform, you can build them with SSDs, it'll cost a lot of money. And so when you think about these large training clusters, our customers demand us to think about very effective ways to bring the total TCO down by doing very smart tiered storage. And so without solving those challenges, customers end up over-provisioning for their peak capacity or how their training may actually be. They end up paying higher costs because they're paying for the block volume. They probably pay for the snapshots or the backups that they're taking in the object storage. And it also puts a ton of burden and operational complexity on the customers. And we said, once again, we're going to go figure out how to solve this problem. And with that, just look at the traditional architectures in terms of how clouds are built. There's a ton of tremendous redundant storage management layers. There is very inefficient tiering that exists at the layers at the bottom, and it leads to higher TCO. And so we're actually building the next generation of cloud storage that is hyper optimized for these AI workloads while still giving the perfect expectations of any application. And so we're now building an extensible architecture that brings all of the various different kinds of hardware innovation at the drive level, be it hard drives, QLC, or NVMEs and SSDs. We're going to have an extensible architecture that fundamentally pulls all of the different drive disk storage together and presents the right layers for block, file, or object layers, ensuring that we do the efficient data tiering on the back end and we pass the cost savings back to you, just like how we do on compute and network. And today, we're still one of the industry-leading per instance storage performance offerings out there in the market. And we believe a lot of the work that we're starting to do around the next generation storage platforms is going to change the game for AI workloads. All right, now I want to talk a little bit about the best price economics. Why do we believe that? What is happening in the industry? How has OCI kept up with the pace? To talk about this, you need to understand what has actually happened in the CPU industry. If you start looking at what has happened over the last 8 years, the performance per core, if you take every individual core that is actually offered, the performance per core has continuously gone up, keeping a little bit with Moore's law. But if you look at the cost per core from the industry, it has actually continuously been lowered. Okay, that's great. Hopefully that should be savings, but not really. When you think about the performance per dollar that is offered on OCI relative to the other clouds, you can see over the years, OCI has consistently passed the advantage and the performance dollars that we gain with all of the great innovation that is done by our hardware partners back to our customers. So when you have the very, very large enterprises betting their infrastructure workloads on OCI, this is an example of a reason why they do. Okay, so that's happened on core. But let's look at memory. Memory is still expensive. So when we look at memory, it follows a very interesting pattern. It almost feels a little bit like oil. There's a supply and a demand curve that actually drives the cost of memory. It's very cyclical. It's very volatile. But memory is such an integral part of building these compute instances. And so as we see and look ahead to AI workloads, what is very obvious and very clear is that the cost curve rewards memory efficiency. And so we took that as on a challenge for two reasons. One, we wanted to help identify economics that we can actually lower the cost for our customers and pass the savings back to you. Second, we also had a very selfish need for the 3-rack footprint that I talked about, the dedicated regions, which actually packs hundreds of OCI services. We needed to find memory efficiency. We needed to know how to place all of those workloads inside those 3 racks. And so what we did is we tried to look at what happens to our services, what do these applications use it for, and more often than not what they do is that they just page the memory and they don't release them. And they don't release them for a good purpose because there are applications that need to respond in very, very short order for the request that is actually coming in. And we said, great, but what if we don't send any traffic? What happens to these 3 racks that we're building, which is a region? And what we found is that 50% of the memory was never released. Applications still paged them in, and they were hanging out. And so we took that as a challenge, first to solve it for ourselves. But what we're announcing is an Oracle Dynamic Resource VM. The fundamental concept behind Oracle Dynamic Resource VM is that we've made optimizations in our Linux kernel that takes a look at the page caches and tries to identify any sort of changes and ensures that the pages are actually kept, the RAM is actually accessible and available. But if we monitor it long enough, we're actually observing that it is just paging the memory in but not releasing it. So we made kernel changes to over-provision the memory a little bit. So when we really need it for the spiky needs, we actually keep them, but all the other times we take the memory back and we pass the cost savings back to customers. It's a very unique idea, and we're just getting started. It may not work for all applications, definitely not for big data applications or other use cases, but it will be great for any sort of web front-end workloads like what OCI services are. But we're just getting started. Because once you actually learn enough about how this workload behaves from a kernel level, we have an opportunity to significantly innovate in this area that no one else has ever done and pass that savings back on to you. So when you think about price economics, not only does OCI offer a very, very powerful performant platform, but we continuously innovate at every layer of the infrastructure to identify the most efficient infrastructure that you can run on. So across compute, network, and storage, we're very proud to offer the most flexible, highest performing, and the most economical cloud infrastructure that you can bet on. All right, with that, I'd like to welcome Albert Greenberg, Chief Architect Officer from Uber, to talk to us a little bit more about his research in OCI. Such a pleasure, Albert.
Amazing talk, amazing numbers.
All right, well.
Exciting journey.
You've been using them, so we're going to talk about that.
Totally.
All right, well, look, Uber's been on this phenomenal journey over the last few years in terms of growth, but also in terms of technology.
Yeah.
Which people don't hear a lot about. And so, first, thank you for joining us. And it'd be good to hear a little bit of your perspective on that.
Wow, it's a pleasure, and thanks for inviting me. I remember when we sat down at a table to discuss, the journey, and and you asked me about what kind of marks you had to hit, and when I think about that meal and that table, I think that who is virtually at that table, and it's the the scale that we have to bring to the world. Thanks for mentioning that people took Ubers from the airport. But our user base is amazing, and we do today service in about 70 countries. We do 15,000 cities. There's 36 million or so rides per day, and our monthly active users is incredible, hundreds of millions. So that's that. And then behind all that is the earners. So we have people whose paycheck depends on Uber, about 9 million of them today. So it's kind of the virtual table always for me includes the users and the earners. And when we were discussing what marks that like you mentioned Oracle has to hit, some of it are these amazing performance numbers, but a lot of it is reliability. And for us, reliability is not a constraint. Reliability is feature one. It is everything. And that's really our focus. And because we're all about those users and earners. And what is I talked about the users and earners, but what does it mean to the workloads? We do about 30 million AI operations per second. So this AI trend is completely real, and that's 30 million AI operations per second on Uber. That translates into something north of 500 million database accesses per second. So the scale is amazing, and the constraints on reliability are also amazing. So when we were talking at that dinner, and why OCI, I could just tell that our teams had the right expertise and the right spirit and energy to achieve those amazing numbers with great reliability. And that's why we chose you. It's been a good ride.
I know. And I think we talked about the dinner, and I asked you the wrong question. So the dinner that Albert's talking about is when both of us sat down and talked about Uber building the next generation in a class of applications and the reliability that he expects out of his cloud partners. But he said, but I know how we can do it together, and we're here.
Yeah.
6 months later. So exciting, Albert. Let me ask you the next question, which is the move from on-prem to cloud is never the flip of a switch. It's a journey. And so, for Uber to actually achieve this amount of scale and just continuously go on, and your guys still ask me computers every weekend, but we're scaling at this phenomenal pace. So it'd be good to hear about sort of your strategy, the reliability at the center of it, how are you thinking about this further?
Yeah, amazing, and yeah, thanks for asking. It's kind of a naive view of cloud migration. We were essentially 100% on-prem when we started late 23. And, people talk about lift and shift. It's kind of a naive way to think. You never lift and shift. It has to be a lift and transform and fit. And that's how we did it. And at the same time, in Mahesh's intro, he talked about multi-cloud, and just to make it more interesting, not just one cloud, multi-cloud, and that was a tenet that we put in to our cloud journey. And then to make it even more interesting, growth. I mean, at the time we were growing at 20+%, and we're still growing like crazy. Growth is really liberating and fun to be part of. And yet we had to not think about where we were at the time, but where we would be in the next 5 years as this growth continued. And at the same time, we wanted to move everything to the cloud. We didn't want to impact at all. All we wanted to, the product teams, the people building the Uber applications, front end, back end, mobile, everything, Gen AI, so forth. We wanted only that their experience gets better, that things run faster, but there's no kind of undue stress on them as we do the cloud migration. So the strategy we took, which is kind of bold, and some of the Uber engineers are in the audience, they made it happen, was to move everything. As we shut down a data center, we didn't move like this app and not that app, and here's a white elephant, keep that. We moved everything, all tiers, all service, from the on-prem to the cloud. And that turned out to be a winning strategy for us. We have the software that makes that work. And that was our, let's say, secret sauce. The one more thing that makes it interesting, and I'm sure you all know that in the audience, is that everything breaks, everything fails. Zones fail, regions fail, networks fail, everything, software fails. And it has to be done without anybody noticing. It's okay. Things fail, we got more things. There's no reason for customers or service to notice as things break. And so we had to do all of that and do it, on a time-based schedule. And it's been a great journey, and so far so good.
Awesome, fantastic. And I know velocity is key at Uber, especially around your philosophy on 4-hour work. So tell us a bit more about what that means and how has it changed, this journey changed the day-to-day for your teams?
Thanks, Mahesh. There's kind of a traditional thing about velocity and quality. If you go too fast, you break things. We've all heard that line. And we can't have that. We have to go fast. We have to, it's just everything is changing. Everything is changing in our service. We have to deliver new features. We ship about 100,000 diffs. Let me see if I get this right. Sorry, let me think. Yeah, 100,000-ish diffs per month. Okay, we have about 6,000 engineers. So it's just amazing. A diff is a piece of config or code. So we are shipping change constantly. And at the same time, we found that like our rate of producing these changes, producing software and so forth, is up 80%, and the incidents that are coming from these changes is down 50%. So we have to find a way, and we found a way to not have quality and velocity contradict each other. Of course, now Gen AI is a big part of how that works.
No, I know that's going to lead us to, AI is transforming every part of the stack. And so what does that look inside at Uber, and how is OCI helping with that?
Yeah, so Uber is an AI first from the beginning company. We have a system which we're going to be making open source called Michelangelo, which allows us to ship AI models just like software. And we have tens of thousands of models shipping and running all the time, every time you open and use the app. So we are always work from the beginning, AI first. But now with Gen AI, that's also picking up. So internally, the developer productivity is shooting up, and basically the productivity of everybody in the company is shooting up. And externally, underneath the covers and actually in the new user interfaces that you use to get to the Uber app, it's Gen AI. So much more reasoning, much more chain of thought, much more logic at every layer of the company. And the partnership with OCI has been fundamental to that. I don't see how we could have made the transition to AI without cloud, without OCI. It's just, there's no way we could have done the GPUs, no way we could have done all that software sitting on-prem. So it's been a fantastic partnership, and I'm just excited for the future.
No, I'm very excited as well, Albert, and I'm looking forward to continuing to read all Uber engineering blogs. You guys keep doing fun work. I like that.
All right, yeah.
All right.
We'll write some together.
Thank you so much, Albert. I really appreciate it. Thank you. All right. As we think about having the distributed cloud, it's everywhere, it enables you to build these applications and move fast. I want to dive into all the things you guys have been reading in the news about Oracle and what's unique, what's different, and why we do what we do. Starts with first understanding the industry challenges. One thing that's clear, as I said, AI changes everything, but at the same time, the adoption for apps that actually do meaningful work is also going up. The monthly inference token count has significantly increased over the last year or so. And so what that tells you is that compute continues to remain a top bottleneck. And if you also look at the number of models that are coming online, there is a massive increase in the number of models that train at a very large scale than they did back in 2023. Also, it's very clear that the number of releases that these different large model players actually go to the market is a significant differentiator for them, which means faster time to train is faster time to market, which means faster time to their value. The third is that there are fundamentally new research paradigms that are coming in online all the time. So an increase in training costs is obviously expected, but it is going up. So as these large LLM folks think about AI infrastructure, price performance at TCO continues to remain a top concern. So what the industry actually requires is choice, scale, performance, and speed. On choice, I want to start talking a little bit about why Oracle's unique and what we do with our data centers that brings customer value. I'm not going to talk about how we build our data centers, but I am going to talk about very key things that we do that gives customers flexibility. So when you think about data centers, whether it be me or anyone else, what do they look for as you start looking into the AI world is to think about how can I use these existing data centers that I signed these very, very large contracts for, including myself. Second is how can I use the power most efficiently for the way I do research or I do my AI inferencing to manage the power that is available for me. Third, have flexibility depending on the type of research or the type of workload that you do, how much storage or compute do you want to place into these data centers. And remember, these are very large data centers, but the demand's very high. And so the first question, what we're trying to do is to ensure we're announcing Oracle liquid-to-air cooling solution that then ensures any Oracle data center can actually become liquid-cooled ready. The second thing that we have done as part of these racks is actually support all of the future generation of GPU racks up to even 1 megawatt. So these liquid cooling solutions can actually be sitting right next to a GPU rack in an air-cooled data center and can actually support up to 1 megawatt of GPU power draw from these racks. So what this does is it enables our customers to get access to GPU compute really, really fast in weeks, not years. So just to kind of visualize how this works, imagine this is a data center, an air-cooled data center. Oracle has the ability going forward to be able to place a liquid-to-air rack solution that we've built and also place a GPU rack right next to it, and it can be mixed and matched. And so this gives customers a lot of flexibility in terms of getting access to compute faster. The second challenge is that when you do and run these large training facilities, something that's very important is the AI workload profile is very different than what a normal application load profile looks like, which means it can cause unpredictable power swings. These power swings and the way they actually swing can have tremendous devastating impact on all of the equipment that we have in the data centers. And second, they also can have large load swings. When you think about operating 100, 200, 800 megawatt data centers, when all of the GPUs finish their work and they stop, they can actually come back down to 300 megawatts. That actually has a tremendous lasting impact on the grid. And so Oracle has introduced and announcing dynamic power management solutions that actually adapts and protects the grid, enables our customers to use the power in the data centers most efficiently, and also ensures that it protects any backing power generation store on the back end. I'm just going to take a moment to talk about what does achieving maximum power utilization look like. So when you think about, let's say, a 100 megawatt data center and you can put in 10, let's say 100 racks, more often than not, depending on the research workload, some customers will want to push the GPUs only up to 80, 90% of those rack capability and use the remainder to actually have more GPU compute. And you need a dynamic solution that actually protects these workloads and ensures that the data centers run fine, the workload has the highest availability, but also gets the maximum amount of flops in a single data center. And Oracle has innovated on that. just to kind of give you a sense of this AI workload profile. So in a typical AI workload profile, if you look at how the power actually swings, this is what the grid would observe, but they don't like it. What we do at using our Oracle's dynamic power management solution is we smooth the curve, and then by the time it actually ends up going to the grid, they see a very, very smooth line. This is a lot of work on the back end across both electrical, software, and control at the rack level that ensures a very smooth experience goes back into the community. Let's talk about accelerators and choice. Oracle today offers a plethora of choices when it comes to AI infrastructure offerings across the board, and these are already announced. But today, we're also announcing that MI355 is completely available in Oracle Cloud Infrastructure with our Zettascale clusters. With that, I'm going to invite Forrest Narod, who's the EVP of Data Centers at AMD, to join me.
Thanks, Mahesh.
Thank you. It's such a pleasure seeing you.
It's always good to see you.
Also with makeup, both of us. It's kind of funny. All right.
No, that doesn't happen every day.
That's right. Well, look, AMD is a leader in the CPU market. We've been using your products for such a very long time, and you've been pivotal to a lot of the growth that OCI has actually seen at the compute part. Can you tell a little bit more about how we've partnered together to deliver that best price performance that customers seem to enjoy about OCI?
You bet. You know, we've been honored to be partnered with OCI for nearly a decade on this CPU journey. You know, starting with their first generation EPYC server CPUs, codenamed Naples, back in 2017, I think it was, with bare metal instances. And then most recently, earlier this year, OCI announced the use of our 5th generation CPUs, codenamed Turin, in both the E6 VMs as well as the X11M Exadata racks. And I think, you know, we've had a fantastic partnership that whole time, and our engineers have done a great job driving 2x performance per core and 70% price performance advantage for your customers just in the last 2 generations.
That's right.
And so because of that, you know, we've seen a very broad adoption in OCI across, you know, bare metal, IaaS, PaaS services, SQL, of course, Oracle Fusion. And that's led to customers like Uber, obviously, PayPal, Palantir, Vodafone, Zoom, amongst others, really embracing OCI and EPYC for their mission critical workloads and being able to modernize and migrate their workloads while getting significant power and price advantages, which they can use to then reinvest in innovation.
That's correct.
I think it's been a fantastic journey together.
Absolutely. I think, you know, it's great. Albert talked a little bit about the price economic story as well. Look, I know everybody knows about AMD on this CPU front. One thing that we don't talk a lot about, although with Acceleron we're announcing it today, AMD has been, Pensando DPUs have been powering our bare metal infrastructure for such a very long time. And we've been doing tremendous work, right? And doing across giving the best performance, but also not compromising security. So maybe why don't you talk a little bit about our partnership in, you know, what we're doing with Acceleron?
Yeah, you bet. I mean, again, I think OCI has been working with Pensando even before AMD acquired it 3 years ago. And I think you were really an innovator in the hyperscale space in the use of DPUs broadly, and because you understood that the DPUs could significantly offload and hence accelerate complex CPU and GPU workloads. And that's particularly important as those workloads scale up. And then the unique thing, I think, about our technology is that the AMD DPU technology is the only one that's fully programmable without any performance compromises. You can implement very complex algorithms, transport protocols, congestion management systems, and get amazing features without giving anything up on performance. And so I think you've used that to innovate at the speed of AI.
That's right.
You know, over the last 3 or 4 years, and I think, you know, you've already deployed I think, ubiquitously
That's correct.
in OCI. But now it's part of Acceleron, and it's super exciting to see the performance and the security capabilities brought to AI networking as well. And I think customers are going to be delighted with that.
I agree. I'm very excited about that partnership as well. You know, we've been doing CPU and DPU. There's also a thing called GPU that we seem to be doing. Maybe tell us a bit more about that.
Another XPU.
XPU,
Yeah.
That's right.
So we've been working together on the GPU side since the MI300X, about almost 2 years ago now, a year and a half ago now. And you know, our engineers have worked together very closely, again, to deploy MI300X based instances and to optimize those instances so that OCI customers are getting excellent performance in both training and inference. And those gains have led to a 10x improvement or a 10x increase in MI300X deployments in a year, and led to companies like Cohere, Uber again, Seeker, and others, you know, really seeing substantial price performance benefits and performance benefits from using the Instinct GPU instances. But I'll tell you, you know, you just had the 355 announcement a second ago.
That's right.
Let me ask you, turn the tables on you. Tell us a little bit about what Oracle is doing with the 355. What are your customers seeing with it?
Look, I think, you know, if you go back to Oracle's philosophy, right, delivering MI355 was, you know, foundational in terms of how we think about flexibility and choice, and delivering the cutting-edge infrastructure that our customers demand and need. And honestly, the adoption that we expect has actually been pretty good. We have quite a few customers. We're very excited about taking the platform on. We're building a few of these clusters globally that ensures that they get access to the data center. Yep, they're very, very busy. And I think it's also crucial to kind of think about bringing sort of the CPU and the GPU and the DPU together and bringing the best of AMD together to our customers. And also, I'm very, very excited to see the progress on all of the software innovation that you guys actually be doing in this space, right? So, yeah, no, it's actually been phenomenal.
It's worked out very well, but there's
and
one more
look,
step to go.
We've been very thrilled about the continued adoption and the momentum of 355, and obviously we still a lot of work to do, and customers are starting to try the platform. But we're deepening our partnership with 455, and so tell us a little bit more about 455.
Well, this next step is really about bringing the next generation of AMD silicon technology, or not just silicon, software as well, technology across the board, and bringing it together into what we think is truly going to be a leadership AI experience for OCI's customers. We're going to be bringing the MI455X to market, which we believe at introduction will be the fastest GPU in the world with the best memory technology, both bandwidth as well as capacity. But it's not just the GPU, it's also the next generation EPYC CPU, the 6th generation EPYC, which quite fittingly for where we are is codenamed Venice. We'll be bringing that one to market. And also the next generation of Pensando technology, both in the AI NIC as well as in the DPU. Now, all of that's getting put together into a integrated optimized rack level system that we call Helios, that's been designed in close collaboration with Oracle and other key customers. And Helios puts together up to 72 GPUs in a pod or in a single rack, very high speed interconnect, making sure they can be welded together into an effective whole. But importantly, it's also based on open standards.
That's right.
So, you know, Helios and that whole family implements the Open Rack Wide standard, the brand new OCP or v3 Wide standard. They implement Ultra Ethernet Consortium standards. They implement Ultra Accelerator Link standards. And it's really emblematic, I think, of AMD's philosophy, which has always been our mantra, about having open, power efficient, highly performant solutions. And I think putting it all together and then having a partner like OCI to bring it to the market first as a launch partner will allow our mutual customers to see tremendous performance, price performance, gains and to get those AI results much faster.
Look, I'm very excited, and thank you for selecting Oracle to be the first hyperscaler to launch the partnership. And we're continuing the journey, trying to get this in the hands of customers. Super excited, and trying to serve multiple customers in generations and beyond, and 26 and 27. Let's see how the scale keeps going up.
That's fantastic. First 50,000 in just about
less than a year.
Less than a year.
12 months.
The teams have got to get busy, and then expanding beyond that. We're really looking forward to it.
I'm very excited to get this in the hand of customers. All right, folks.
It
was a pleasure. It was fantastic. Thank you for the partnership. All right. So that gives customers more choice, and it's very exciting. But you can't talk about AI infrastructure without talking about all the great things that NVIDIA has been doing in the market. And so we're announcing the NVIDIA OCI compute with NVIDIA HGX B300s that's now available to our customers. We're also announcing the most powerful platform from a liquid cooling rack perspective on OCI compute with NVIDIA GB300 and NVL72. And also for very select customers who are very specific about how to do inferencing at scale, we also have NVIDIA RTX Pro 6000 that is also available on OCI. That gives a full plethora of choices across the board. I'm going to jump into superclusters. For folks who know, a supercluster is a combination of hyper-optimized infrastructure at the data center level, at the power level, at the network level, at the compute that puts it all together, and eventually running giant, large training jobs. And last year, I announced a Zetascale OCI supercluster up to 131,000 GPUs. And today, we're announcing OCI Zetascale 10, which is up to 800,000 GPUs in a single supercluster. And when people always ask me, is bigger better? And in this case, it is, because when you think about these large training models that actually do a tremendous amount of research, very, very large clusters can bring up to 10% optimization on TCO for these large LLM players. And 10% at this scale is a phenomenal amount. And that's why OCI invests heavily in scale with a lot of our partners. Zetascale 10 delivers 2.5x higher cluster front-end throughput than what it did before, up to 131 petabits per second. It delivers a phenomenal 2.1 exabits per second in under 10 microseconds. So for folks, they use different words. I want to say 2000p 10U network, if that helps. And so it essentially is the largest AI supercomputer with NVIDIA chips. So the campus can be up to 1.5 gigawatts of power within a 1.5 kilometer of data center radius, offering 16 zettaflops, 800,000 GPUs of the current generation NVIDIA, with phenomenal networking backed by Oracle Acceleron. This is the largest AI supercomputer in the world. With that, I'm going to invite Ian Buck from NVIDIA, who's also the co-founder of CUDA. Ian. Such a pleasure, Ian. Such a pleasure.
Yes, excellent.
I don't know. When we have some time, breathing time, room, from building all these giant clusters, we get to talk about that stuff too.
It's nonstop. They keep coming, and the demand keeps. There's no shortage of demand.
I know. I say more no's than yeses. But anyhow, let's talk to people about all of the great work that NVIDIA and Oracle have been doing. NVIDIA is known, obviously, as a leader in AI infrastructure from a GPU standpoint. But I also know that you guys have been working on a vertically integrated networking stack. So tell us more about it.
Yeah, we just talked about the scale of what we're operating at, and how these super Zeta clusters come together.
That's right.
Training a lighthouse model is it is a mission. It's a rocket ship to Mars. Everything has to come together.
That's right.
To give you perspective, the corpus of the internet is about 400 terabytes of data. And that's only sort of the beginning of, those were models that were probably trained back in 2004, 2003. Today, all those weekly users of GPT and other models are generating data. They're generating information, they're generating knowledge, they're thinking, and that thinking goes into further training. That knowledge becomes part of the model itself. Today, I think Sam said he has over 800 million weekly average users. All of that becomes new knowledge, new thought that can go into training the next generation model. And now, of course, we're doing with multimodal models like, if you're using Sora, you're using a GB200 at OCI. Making all that training happen requires all those connections, all those GPUs to work as one giant GPU. Today, GB300 is connected with NVIDIA CX8 networking.
That's right.
And all connected with Spectrum-X Ethernet. We've been investing in Ethernet for quite a while now, actually. Ethernet is the network of scale, but it was designed to run your email, browse the web, or run your IT backbone. When you're training a model like GPT or at the scale of Zetascale, it's a little bit different.
That's right.
Every single port, every single NIC, every single GPU running at 800 gigabits is trying to talk to every other one. And that is you can't just take a standard Ethernet to do that. You have to build a new kind of networking switch that scales. And that's what we've done with Spectrum-X. And we announced earlier this week that the Abilene Stargate cluster is built on a Spectrum-X backbone. That was actually achieved by having such an open platform with Spectrum-X, of developing the software in order to deploy at that kind of scale, working with the Oracle engineers and of course OpenAI. And as a result, we can achieve a full 95% of the max throughput of the entire data center when everyone is talking to everybody else. It's a miracle achievement. It's a challenging task, but it makes the AI that everyone here is enjoying possible.
That's right. That's right. And look, the Zetascale 10 clusters that that we're going to be building, or we are building with NVIDIA GPUs, is a new frontier in performance and scale, and it's been phenomenal. So when we talk about hyperscale compute, and now at the Zetascale, is this compute to enable bigger training, bigger models, more sophisticated models? What is actually being used for?
We're in the era of now reasoning.
Right.
Models actually, before when you used a simple model, it would tell you what it knew. It was baked into the model and give you that answer. It would do that in like 100 tokens or 100 so odd words. It would just sput it out. And as you can tell, it tried its best, but sometimes it would hallucinate and just make stuff up. It really wants to answer the question, even though it doesn't know it. Today, modern models like DeepSeek R1 and GPTO, they are thinking models. They generate thousands of tokens. So, and by doing so, they're actually trying to think out loud, and you don't always see that, you see a scroll bar, but they're generating thousands of tokens to actually give you the right answer. They're also connecting to the internet and pulling data from the internet, so we're seeing an explosion in the amount of inference that's being performed. Models will consume thousands, if not 1 million tokens or of information before answering your question.
That's right.
And it will actually generate tens of thousands of tokens before giving you the answer and coming up with the right answer and using that context memory. We've been swarming inference for the last few years, and so has everybody else. And they're all doing it on NVIDIA platforms, of course, available on Oracle for the customers. And the performance is like remarkable. I think since the original GPT open source model came out, the community, not just NVIDIA, but engineers at Oracle and across the open source world and the AI world, have improved the performance of the open source GPT by 5 times.
Yeah.
And that just goes straight to the infrastructure that you've already rented, that you're already using. You can know that when you're on NVIDIA and at OCI, that you're getting that performance improvement of the entire world's AI researchers deployed into that software, and it just runs faster. I think this is one data center. This is the first time I think data centers, they're becoming an appreciating asset in terms of their value to the customers.
That's true. That's true. Look, I think customers do, a lot of customers, on OCI, both training and inferencing, use a phenomenal amount of GPUs from NVIDIA. As a trusted partner with NVIDIA, we not only do offer enterprise and NIM services, but also we use them in Oracle Fusion applications a lot. And we've deployed them, globally for all of our customers with the integrated stack. So what do you see as the most transformative outcomes emerging from our partnership as we look ahead to the future?
Well, Oracle, at its roots, is a data and database company. Connecting the world's data, the world's enterprise data is stored in the Oracle database. And we're super excited about the Oracle 26 AI announcement, which now runs on NVIDIA GPUs. It's bringing that AI technology into the database. So it can do things like vector search. You can vectorize all your data. Vectorization, or tensors or vectors, is the baseline of how people represent data in embeddings of your data to apply the AI. Now is embedded inherently into the Oracle database, so that when users can now ask questions of their data, they're running an AI model using NVIDIA's vector libraries, QVS, also using our NeMo retriever library, so that actually the AI model is directly integrated into the Oracle database and back to the users. So for the first time, it's not just a tagline, it's actually happening in Oracle's database. You really can ask questions of your data in Oracle, in the Oracle database, Oracle Database 26 AI, and get the answers in real time. That special relationship that we have, NVIDIA, which is just so focused on accelerating computing, accelerating AI, bringing all those core technologies, and Oracle's own engineers that know data, know databases, know how to do queries. We really make the whole is so much more than some of the parts, and it gets delivered immediately to customers.
No, and look, it's a phenomenal partnership where we actually start from the infrastructure layer, but go up the stack, all the way to the Fusion application. So the partnership is actually integrated at every level, focused on delivering customer value. So thank you, Ian.
Thank you, Mahesh.
I really appreciate the partnership and looking forward to launching bigger clusters soon. All right, see ya. Thank you. All right, we talked about scale. I'm going to touch on performance next. As I mentioned, the heart of the superclusters is the networking. So traditional networks have these three-tier architecture that cannot support modern workloads. And so we introduced Acceleron, which has three fundamental foundational concepts, which is the accelerators, which are the DPUs, the fabric architecture that puts the network together to give you that high performance, and third is the networking suite of software that accelerates all of the information in the cloud really fast. And today we're announcing a converged NIC concept, which essentially gives you the security properties that I talked with Forrest about by developing a new generation of smart NICs that places two NICs, but it has the isolation properties of a security layer that ensures customers get the best performance without compromising any of the security. And this delivers better throughput that enables new kind of workloads that were never possible, especially with the advent of AI. We announced zero trust packet routing last year. This is a fundamental new concept in the way we actually think about how we expect security engineers and application engineers need to work, but they still get the outcomes without compromising by moving the security to the infrastructure layer. And today we're announcing private service access. When I talk to customers building applications, they talk about public endpoints that certain apps or services actually allow them to place, even though they have security policies. And so Oracle is today introducing a secure access capability. So every host where you're running a workload can have direct private secure access to that particular service. In addition, you can add a deny policy that prevents any sort of endpoint access from the public internet. On the architecture side, traditional TCP has many challenges around flow congestion and retransmit, which essentially forces more cores being spent transmitting packets. Oracle, once again, is inventing the first of its kind, developing RDMA on the front end, leveraging the advantage of the low latency network and predictable and higher performance that we can actually offer for customers. This not only saves the cores on the boxes in making the kernel do the work to spend more cores, but also gets you performance on the network, essentially getting the maximum out of the storage services that it's talking to. Another key advantage and announcement that we're making is really redoing how we think about the network. If you think about a traditional network, there are multiple failure points in the network that prevents your host and your instances to be available. Oracle obviously builds a ton of technology around available, either be it K-splice or live migration that we offer on our cloud. But we went back to the drawing board again, asking the question, why do these single points of failure exist? And what can we do to change that? And we introduced the concept of multiplanar fabrics, which foundationally combined with Acceleron, presents a single uniform network layer to the host and the applications, but truly has a multi-plane or multiple planes of connectivity, enabling higher availability for your network, better reliability, and things that Albert talks about with the reliability expectations of our top customers can be served with Oracle's Acceleron. And when you think about, when you think about a cloud where you're running multiple hundreds of instances, there's packets that are going all over the place to go from A to B, because they could be very, very large data centers. But one of the things that we intend to solve with our Fabric accelerators is a suite of software essentially intelligently knows where the packet is destined much faster than a traditional route convergence logic. And so we're introducing this concept that ensures customers can actually take the packets from the host that they're operating at to the destination really, really fast, and removing all of the middle layers that ensures the latency is really small. Also, when you combine this with Zipper, you get that advanced security of going from A to B really fast. So Acceleron fundamentally is the foundational networking technology that Oracle is built on top of. And we're introducing 5 new capabilities today that is going to make the workloads that run on OCI more performant, more efficient, and more secure. With that, I'd like to welcome Ken Duda, one of the co-founders and VP at Arista. All right, Ken. Welcome. Thank you so much. Let's take a seat.
Thanks for this amazing show and this great audience. Thank you all for being here.
No, it's fantastic. Once again, we've been working together for a decade. I've been building all of these phenomenal networks that people are enjoying. So maybe we start talking about how have been working together and how are we achieving these outcomes?
Look, one of the great privileges of my position at Arista is getting to work with people like Mahesh. Our company gets to work with the biggest deployments in the entire world, and it's a nerd dream come true, with partnerships that are built on a foundation of trust, mutual respect, and then execution. Sitting down, figuring out what do our customers need, how are we going to solve this, and listening to the real problems, we come up with solutions, commit, execute, and deliver. And we're super proud of what we've achieved with Oracle. We're very proud to be a gig-scale partner. What we've now seen that come to life with Acceleron and years of building the OCI infrastructure. So thank you for that partnership.
No, that's fantastic. And one of those slides are up there that you sent me about all the work that we've been doing since the beginning of bringing Exadata on OCI. Look, why don't we talk a little bit about what as AI adoption continues to go up, our continued innovation and our partnership. What does that future look like? Where are we headed?
Yeah, well, we start from a real strong foundation. We did some of the earliest RDMA networks, Rocky, RDMA over converged Ethernet, and that gave us the right foundation to get ahead of the AI curve and provide the kind of fabrics that are required for the sort of exabit scale AI fabrics that Oracle is building. Those are powered with our switches because our switches have that kind of capacity, have that kind of fabric scalability. There's some unique challenges with AI. The ability to load balance across a multi-tier fabric, you've got to avoid hotspots. Hashing is not enough. The GPUs are going to stall if even 2 flows hit the same link. And so we have advanced load balancing algorithms that enable these kinds of scale GPU architectures. But we bring other advantages as well. The ability to have the same switches both in the back end of the AI network, but also in the front end, where the AI cluster is attaching to all the other services in the data center, the fabrics, the databases, the storage systems, out north-south traffic, out to the end user, and having the same switches in both of those areas means operational simplicity. It means unified management. It means a single, simple architecture for the entire data center. Only Arista can deliver this.
No, this is phenomenal. So looking ahead when we talk about these new technologies, how is that going to bring more value to customers, right? Especially running on OCI?
Well, we're going to keep innovating. So in partnership with Oracle, we're both standing behind Ethernet as a foundational technology. Betting against Ethernet, not a good plan. Anybody heard of FIDI or HIPPI or ATM or Sonnet? Ethernet the Ethernauts lose every time to Ethernet. Simple reason is Metcalfe's law. The value of a network is quadratic in the number of attached endpoints. So we know Ethernet's going to win. The question is, how do we make Ethernet serve AI as well as possible? And that's where Oracle and Arista have been working together in the Ultra Ether Consortium, enhancing Ethernet to improve load balancing, to improve congestion management, and to improve the transport for sending AI results, partial matrices, collectives across the network. I think those innovations are going to be really important as well.
No, it's phenomenal. And I think if you think about where Oracle's journey started with actually betting on Rocky back in 2018, just for accelerated workloads, and then it evolving itself to AI. And you guys have been a fantastic partner in that journey and supporting us with a tremendous amount of work and innovation. And glad to have you as a great partner for Acceleron.
Likewise, I'm sure.
Awesome. Thank you so much, Ken. Really appreciate it. Thank you.
To all of you.
Thank you.
All right.
All right, we're going to wrap this up. The last thing is, while we have flexibility, choice, scale, and performance, it is also important to bring these compute really, really online faster at the speed of age of AI. So why don't we play the video of what we've been building over the last year. What you actually saw was one of these Zscale 10 clusters actually in construction. And if you look at what Oracle is actually achieving in the market, is we're going from dirt to model research in less than 1 year. And it's up to 50% faster than any other industry average, delivering for our customers at phenomenal speed. Oracle Cloud Infrastructure has one of the most powerful AI infrastructure, the Zscale 10 announcement. We have large customers completely betting their entire platform on top of us. And with Oracle Acceleron, we're delivering breakneck performance on the network for our customers. The world's AI is still being built on top of us. Come join us.